Welcome to our today's session. Today we will be doing short tricks on time, speed and distance. So let us begin. So as we all know, we have studied time, speed and distance. We have been studying from school itself. So we know the formula of speed, isn't it? So what is speed? Speed is given by distance divided by time. The distance traveled in the given time will give us speed. If speed and time is given, how to find distance? Distance is nothing but speed into time. And if speed is given and distance is given, then how to find out time? Time is nothing but time goes here and speed comes here. It is distance divided by speed. Okay, these are the three main equations or formulas we need to remember. Then from these formulas we can say that speed is directly proportional to distance, where time is constant. Time is constant. Speed is directly proportional to distance when time is constant, and speed is inversely proportional to time. We can see in this equation, that is, speed is inversely proportional to time when distance is constant. When distance is constant. So speed and time are inversely proportional and speed and distance are directly proportional. That is, if time taken is more, that means that speed is less, and if speed is more, it means that time taken will be less. So they are inversely proportional. So these are some important things we need to know before starting the problems. So let us begin with our first problem. So I have divided the time, speed and distance problems in different parts. So what are those? First let me see that. First is concept of ratio. Means I will use ratio concept in solving the problems, and that itself will be the short trick. Okay, the concept of ratio will help us to solve time, speed and distance problems in a very few seconds. Okay, so how is that? We'll see in this topic. Next, average speed. How to find out problems in which average speed concept is involved. Okay, so how to solve in very few seconds the problems having average speed concept. Then we have early and late concept. Early and late concept. That is, there will be some problems that if a person travels at so and so speed, he will reach the school in a given time. But if he increases his speed and he is some minutes late, but if he increases his speed, then he will be early by some minutes. Okay, like those type of problems will be there where early and late concept will be included. So those problems, how to tackle with those and how to solve those using short tricks, we'll learn in this part. And the last part is miscellaneous problems. Some miscellaneous problems I will include in this part. So the time, speed and distance problems I will cover in these 4 parts. Okay. So let us begin with our first problem and first concept, that is concept of ratio. So in that, our first problem goes like this. A train running at 9:13 of its own speed reached a place in 39 hours. How much time could be saved if the train could run at its own speed? Okay. Means there is a train which is running at 9:13 of its speed, of its own speed. If its speed is something x, okay, it is running 9/13 of its speed and it reached a place in 39 hours. Okay. So if that train had travelled at its own speed, okay, if it had travelled at its own speed, then at what time it could reach and how much time it could save. Okay, how much time could be saved, they are asking. So current speed of the train, means now at what speed it is running? It is running 9/13 of its own speed. Own speed means let it be original speed. Okay, so it is running 9/13 of its original speed. Okay, that is current speed is 9/13 of its original speed. Okay, so from this I can say current speed by original speed, bringing this side, is equal to 9/13. Okay, so from this it can be said that if original speed of the train is 13 parts, then current speed will be 9 parts. Okay, therefore current speed to original speed ratio we got as 9:13. 9/13 is nothing but 9:13. Okay, and here distance is constant because it is same, for same distance they are asking how much in how much time it could reach that place and how much time it could save. Okay, so this from this we can say that distance is constant, isn't it? Now this is speed ratio. Whatever we got, this 9:13 is speed ratio. So time ratio will be what? Time ratio is, we know that speed is inversely proportional to time, isn't it? So time ratio will be inverse of this, that is 13:9. Okay, that is if current speed is 9 parts, then time taken will be more, because if speed is less, time will be more. Same way, original speed is 13 parts and time taken will be 9 parts. That is, if speed is more, time taken will be less. So if this is the speed ratio, time ratio will be inverse of that. So it is 13:9. Okay. So what is the difference between these both ratios, 13 parts and 9 parts? The difference is 4 parts. Okay. Then, so they are asking us how much time could be saved. So this 4 parts is nothing but the save in the time, isn't it? So we know that if it is running at current speed, it is taking 39 hours, isn't it? So that means 13 parts is 39 hours. Okay, so that means 4 parts is how much? Because we want to, if it is running at original speed, how much time it will save, isn't it? That means in ratio it is saving 4 parts. So in actual value, how much it is saving? So this divided by this, 4 divided by 13 into 39. 13 ones are 13 threes are 4 threes are 12. So it is 12 hours. So if the train runs at its own speed, it will save 12 hours. Okay. Save in the ratio is 4 parts. Okay. So that, and 13 parts is the time taken currently. So and time in hours we know it is 39 hours. So 13 parts is 39 hours. 4 parts is how much? So 4 parts is 12 hours. So it can save 12 hours. So option B is the answer. So with this ratio method we can solve the problems easily. Any problem, if you convert it into ratio, we can solve them very easily. So next problem. A boy goes to school at a speed of 5 km per hour and return to the village at a speed of 4 km per hour. If he takes 4 hours and 30 minutes in all, what is the distance between the village and the school? Okay. So what is that they are saying? A boy goes to school at a speed of 5 km per hour. Okay. A boy from village to school, he goes from village to school at 5 km per hour speed. Okay. And return to the village at the speed of 4 km per hour. Means from school he is returning back to village at 4 km per hour. Okay. If he takes 4 hours and 30 minutes in all, okay, that is from village to school and school to village, totally he is taking 4 hours and 30 minutes or 4.5 hours you can say. Okay, 4 hours 30 minutes he is taking in all. So what is the distance, okay, between village and school? Distance is how much between village and school is asked. Okay. Now, speed from, so distance is constant. Okay. So, speed from village to school is 5 km and school to village is 4 km. So, I can say it is 5:4. Okay. Speed is 5:4. This is from village to school and this is from school to village. The ratio between that is 5 km and 4 km. So that I will directly take it as ratio as 5:4. So speed ratio is 5:4. Then what will be time ratio? Opposite of that. It will be 4:5. Inverse of speed is time. This is when distance is constant. Okay. No need to write. I am just telling you all. Then we know that total time, okay, total time he is taking 4 hours 30 minutes. So total time in ratio it is how much? It is 9 parts, isn't it? 4 plus 9 is 4 plus 5 is 9 parts. So 9 parts is equal to 4.5 hours. So they are asking what is the distance between the village and the school. So we'll see how much is 4 parts. Okay, you can either calculate 4 parts or 5 parts. Okay, anything. So 9 parts we know it is 4.5 hours. So 4 parts is how much? That is from village to school it is how much I will find out. The only time between from village to school. Okay. So this divided by this, it is 4/9 into 4.5. Okay. Or it is 4/9 into 45/10. So it is 9 ones are 9 fives are 5 ones are 5, 2s are 10, 2 ones are 2, 2s are. Okay. So it is 2 hours. Okay. So from village to school, that is 4 parts is from village to school, isn't it? From village to school, how much time he'll take? He'll take 2 hours. Now we know time from village to school and speed from village to school, that is 5 km. So from this we can calculate distance. So distance is nothing but speed into time. So from village to school we know speed also we got, time also we got. So speed is how much? 5 km per hour and time is how much? 2 hours. So it is 5 into 10, 5 into 2, 10 kilometers. Okay, so the distance between village to school is 10 kilometers. Okay, not necessary you have to take 4 parts. If you take 5 part also, you will get the same answer. Okay, so option B is the answer. See, by taking ratio, by converting everything in ratio form, we can solve the problems very easily. Now, going to the next problem. Okay. Ram and Ajay start simultaneously from a place A towards B 60 km apart. Ram's speed is 4 km per hour, less than that of Ajay. Ajay, after reaching B, turns back and meets Ram at place 12 km away from B. So, what is Ram's speed? So, what they are saying, there is a place, okay, that is from A to B. Okay, there is, which is 60 km apart. Okay, then Ram and Ajay both will start simultaneously, means at a time Ram and Ajay both will start from A. Okay, Ram's speed is 4 km per hour, less than that of Ajay. We don't know how much is Ajay's speed, but Ram's speed is less, 4 km per hour less than Ajay. So Ajay, after reaching B, means Ram's speed is less as compared to Ajay. So what will happen? Ajay, after reaching B, he'll reach B and he comes back. He'll reach till B and he will come back and meets Ram. By the time he comes back here, that time Ram will come. Okay, Ajay will go like this and then he'll come back like this. Okay, that time he will meet Ram. Okay, so Ram has covered only this much distance. So, and meets Ram at place 12 km away from B. So, this distance from B, it is 12 km. Okay, so what is Ram's speed, they are asking? What is Ram's speed? Okay, speed of Ram is how much? What is happening? There is a place between A and B which is 60 km apart. Total distance between A and B is 60 km. And Ram and Ajay are two people who are simultaneously starting from A towards B. So Ram's speed is less as compared to Ajay. How much it is less? It is 4 km per hour less than Ajay. Okay, so Ajay's speed is more as compared to Ram. So what happens when they both start walking simultaneously? Ajay, since his speed is more, he will go fast and touch the point B and then he will come back. He starts coming back. So when he is coming back, that time he will meet Ram at some point, maybe this point. He will meet Ram because Ram has covered only this much distance. Okay. Then Ajay has covered this much plus he is coming back like this. So what is the distance which he has come back? It is 12 km from B. When he has covered 12 km from B, that time he will meet Ajay at this point. Okay. So what is Ram's speed, they are asking. So all this data they have given and they are asking what is Ram's speed. Okay. Now see here, what time Ajay is taking to go from here till and come back till here, that time is equal to the time travelled by Ram till here, isn't it? So that means time is constant. Time is constant because Ram, whatever time he is taking, okay, Ram, whatever time he is taking to come till here, in that much time only Ajay has gone till here and he has come back. He has gone till B point and he has come back here. Okay, so time is constant. That means Ajay's time is equal to Ram's time. Okay, then so how much Ajay's time is equal to Ram's time, we know. Now what is Ajay is to Ravi's distance ratio? See here, distance covered by Ajay is how much? He has covered 60 kilometer and plus this 12 kilometer, isn't it? 60 plus 12. And Ram has covered how much? So from 60 minus 12. Okay, means still 12 kilometers is remaining. That time only he will meet Ajay, isn't it? So 60 minus 12 is the distance covered by Ram. So it is 72 kilometer for Ajay and 48 kilometer for Ram. So this is 12 6 and 12 3 sorry 4 so it is 2 2 2 3 so Ajay is to Ram ratio we got is 3 is to 2. Okay, this is distance ratio. Now we know in previous introduction I have told you that when time is constant, okay, time is constant, speed is directly proportional to distance, isn't it? So whatever is speed, that only is the distance. So since the distance ratio is 3 is to 2, speed ratio is also 3 is to 2. Okay, speed is directly proportional to distance. Okay. Now the difference between this ratio is how much? 1 part, isn't it? And the difference between Ajay's speed and Ram's speed is how much? 4 kilometer per hour, because Ram is taking 4 kilometer per hour less than Ajay. So the speed difference between Ajay and Ram is 4 kilometer per hour, and the difference between their ratio is 1 part. So 1 part is 4 kilometer per hour. Then they are asking us Ram's speed. So Ram's speed is in the ratio 2 part, isn't it? So 2 part is how much? So it is 2 by 1 into 4, which is equal to 8. Therefore Ram's speed is how much? Ram's speed is 8 kilometer per hour. Okay, so option B is the answer. Next problem. Distance between A and B is 96 kilometer. Okay, there is a place A and B. The distance between this place is how much? 96 kilometer. Two persons P and Q having speed 50 km per hour and 70 km per hour starts from A to B simultaneously. Okay, there are two people P and Q. P's speed is 50 km per hour and Q's speed is 70 km per hour. Okay, they simultaneously start from A. Now Q reached B and returned immediately. Okay, he both start at the same time, but Q reached B and returned immediately. Okay, and meet P at a distance x. Okay, since P's speed is less, he will travel slowly. What in that time what will happen? Q will reach B and he is coming back. So at one point, okay, at one point they will meet. Okay, so that means P has covered only this much distance. Okay, so they will meet at a point x. Okay, so x kilometer from B. Okay, they meet at a point x kilometer from B. So find the value of x. So what is the value of this x they are asking? In the previous problem, what had happened? They had given this x value, that is 12 kilometer. They were meeting at a point 12 kilometer from B, isn't it? They had given this value, but now they are asking that value. Okay, same type it is. P and Q are two people. P is having speed less than Q. So Q will go to point B and he'll come back. Okay, and P till he comes back, P will reach that point. So at one point they both will meet. Okay, so Q has traveled some distance from B till that meeting point, isn't it? So what is that distance, okay, from B till the point they have met? So what is that? X kilometer, the distance they are asking. Okay, so now we know that P is to Q, speed is how much? There's 50 is to 70, isn't it? That is nothing but 5 is to 7. Speed ratio is 5 is to 7. So we know that speed is directly proportional to distance. Since speed is 5 is to 7, distance is also 5 is to 7. Okay. Now, if P covers 5 parts, okay, P is covering 5 parts, then Q will cover 7 parts, isn't it? So now I can say that if this is the distance, okay, if this is A and B, okay, and P and Q are starting simultaneously. So P has covered 5 parts, okay. So this is the distance covered by P, isn't it? They are meeting at this point, and this is the distance covered by Q. Okay, so P has covered 5 parts and Q has covered totally how much? 7 parts, isn't it? From the ratio. So now I can say that P has covered 5 parts. Okay, so Q has covered 7 parts. So till here, till this point, we can say the distance is 5 parts, and this distance is how much? Remaining 2 parts, because this whole distance, if it is 7 parts which is covered by Q, this much is the distance covered by P, so it is 5 parts. So the remaining this distance is how much? 2 parts, isn't it? This is 2 parts, but 2 parts how it is? Q will go from A to B and then again come back, isn't it? That means the distance between this point and B is 1 part, because he is coming back, isn't it? So it is 1 part and he'll come back, so that will be again 1 more part. So it is A to B, it is totally 6 parts. Okay, once again let me tell you all. Now see here, the distance ratio what we got, it is 5 is to 7. Okay, now this means that P has covered 5 parts and Q has covered 7 parts. Okay, now we know P and Q will meet at one point, maybe this point they are meeting. So till here P is covered 5 parts, then we know that Q has totally covered 7 parts. Okay, totally 7 means till here it is already 5 parts, we know. So this remaining is 1 part, okay, which will go till B, and again 1 part which Q is coming back. So totally it is 2 parts. Okay, so total travelled by Q will be 7 parts. So the total distance from A till B, it is 5 parts plus 1 part, it is 6 parts. Okay, then we know that 96 kilometer is the distance between A and B. That means 6 parts is 96 kilometer. Then what is 1 part? Because this much is only 1 part, isn't it? Because 5 plus 1 is 6 and again 1 he'll come back, Q, isn't it? That will be 7th part of his. Okay, so 1 part is how much? This is only 1 part. So it is 6 ones are 6 ones are 6, 6 6 are 36, so it is 16. So 1 part is 16. Therefore, we can say X is equal to 16 kilometers. Okay, option C is the answer. Now going to second type of problems where average speed concept is involved. Okay, average speed concept problems. Okay, from here onwards. So what is average speed? Before we go to the problem, let me see what is average speed. Average speed, how we calculate? It is nothing but total distance divided by total time. Okay, total distance divided by total time is nothing but average speed. So in that, let us see the first problem. A man covered 1/3 of his journey at a speed of 20 km per hour. Okay, a man is covering 1/3 of his journey at 20 km per hour and 1/4 of the remaining at 25 km per hour. Okay, 1/4 of the remaining he is covering at 25 km per hour, and the remaining journey, this is very important. Okay, and the remaining journey at a speed of 30 km per hour. Okay, so then what is the average speed of man? So he is covering different distances at different speed, isn't it? 1/3 at 20 km per hour, 1/4 of the remaining at 25 km, and the remaining at 30 km. So speed is different for different distances. So what is the average speed of the man they are asking? Okay, so to solve such problems, what we can do, the shortcut trick is take LCM of the different journeys speeds what they have given. Okay, LCM of 20, 25 and 30, these are the different speeds given, isn't it? So what is the LCM of 20, 25 and 30? It is 150. LCM is 150. LCM of all these. Okay, now total distance, so this will be nothing but total distance. Okay, so total distance is how much? So whatever LCM we got, that only is the total distance. Okay, total distance is 150 kilometers. Okay, and 1/3 of 150. Okay, total distance is 150. So 1/3 of 150 he is covering at 20 km per hour, isn't it? So 1/3 of 150 is how much? It is 3 1s are 3 5s are 15. So it is 50 km. So time is distance upon time, distance upon speed. So distance is 50 km. He is covering at 20 km per hour speed. So it is 2.5 hours. He's 5 by 2 is 2.5. So he's taking 2.5 hours to cover 1/3 of 150. Then 1/4 of the remaining they are saying. Now 50 has gone, isn't it? From 150, 50 km has gone because 1/3 of 150 is 50. So remaining is how much? 100 km. So 1/4 of the remaining he is covering at 25 km per hour. So 1/4 of 100 is how much? It is 25, isn't it? So time will be how much now? 25 kilometer and speed is how much? 25 km per hour. So it is 1 hour. So T is 1 hour. So 1/4 of the remaining he is covering at 1 hour time. And the remaining journey they are saying. Now 25 is gone out of 100 and the remaining will be how much? 75 km is remaining, isn't it? So remaining journey he will travel at 30 km per hour. So time will be again, distance is 75, speed is 30. So it is 15 2s are 15, 5s are again it is 5 by 2, therefore it is 2.5 hours. Okay, so the remaining journey again he is covering at 2.5 hours. So total time, okay, total time how much he is taking? He is taking 2.5 plus 1 plus 2.5, it is 6 hours. So total time he is taking 6 hours to complete 150 kilometer. So therefore average speed, we know it is total distance divided by total time. Therefore average speed is equal to total distance is 150 kilometer and total time is 6 hours. So it is 6 1s are 6 2s are 12, 6 5s are 30. Therefore it is 25 kilometer per hour. Okay, the average speed is 25 kilometer per hour. So next problem. So option D is the answer. So now the problems are next type, that is early and late concept problems. Okay, now the problems I solve is based on early and late concept. Okay, so how to approach these type of problems and how to solve them using short trick we will see now. Now Ram goes to school at the rate of 15 km per hour and reached 15 minutes late. Okay, Ram, when he is traveling at 15 km per hour, he is 15 minutes late. Next day he goes to school with 20 km per hour and he is 5 minutes before. When he is going with 20 km per hour, he reached 5 minutes before, that is 5 minutes early he reached. Then what is the distance between his home to school? Okay, so see here, when Ram is traveling at 15 km per hour, okay, he is getting late. How much late he is getting? 15 minutes late, isn't it? Then when he is traveling at 20 km per hour, he is early. So how much early he is? 5 minutes early. Okay, so now if I take for example 10 o'clock is the exact time where he has to reach. Okay, if he goes as 15 km per hour, 15 minutes late he is, that means he will reach at 10:15. And when he is going at 20 km per hour, he is 5 minutes early, means he is reaching at 9:55, isn't it? So what is the difference between this time? 10:15 and 9:55, it is 20 minutes, isn't it? 20 minutes is the difference between the time. Now this problem will solve it in two types, traditional method and shortcut method. Okay, so first we'll see with traditional method. Now distance D is constant. Distance between home and school is constant, isn't it? Distance is constant. So when distance is constant, that is time taken to go from home to school minus time taken to come from school to home is equal to the total time or the difference in the time. Okay, so distance is constant, so D divided by speed, that is 15 km from home to school. Then from school to home is again distance is same but speed is 20 km and difference between that time is how much? 20 minutes we got here. So 20 divided by 60, because this time is difference in time. Okay, then why divided by 60? Because it is in minutes, we'll convert it into hour, because this is in hour, isn't it? 50 km per hour, 20 km per hour. So this minutes also I want it in hour, so 20 divided by 60. Now when you solve this, taking LCM of 15 and 20, it is 60. So it is 15 4s are 23s are, that is 4D minus 3D, which is equal to 2 1s are 2 3s are, it is 1 by 3. So it is 4D minus 3D is 1 by 60 is equal to 1 by 3. That 1D is equal to 1 by 60 and 1 by D by 60 and 1 by 3. 3 1s are 3 20s are. Therefore D we got it as 20 kilometers. Okay. The same trick how to solve using a shortcut method. Okay, short trick. For this you should remember just one formula, and this formula will help you to solve all the problems. That is, distance is equal to S1, that is speed 1 minus into speed 2 divided by speed 1 minus speed 2 into difference in time. If you remember this one formula, you can solve all the problems regarding early and late concept. Okay, so D is equal to speed 1, we know it is 15 km, speed 2 it is 20 kilometer per hour, then the difference between them s1 minus s2, 20 minus 15 is 15 minus 20 or 20 minus 15, just forget the negative sign, just take the difference between them. So it is 5 into difference in time is 20 minutes, isn't it? That also in hour, 20 by 60. So it is 5 ones are 5, 4s are 20, 4 ones are 4, 15s are 15, 15 cancels, therefore D is equal to 20 kilometers. So in such a simple step we got the answer. Instead of doing this all thing, taking LCM and then taking difference and all, instead of doing all this, if you just remember this one formula, you can solve all the problems. Okay, so option A is the answer. Now next problem. Due to bad weather condition, an aircraft reduces its speed by 200 km per hour and reaches 30 minutes late in a flight of 1200 km. Calculate usual speed of the aircraft. Okay. What they are saying, due to some bad weather, an aircraft reduces its speed by 200 km per hour. Okay, and reaches 30 minutes late in in a flight of 1200 kilometer, that is 1200 kilometer distance. So calculate usual speed of the aircraft, they are saying. Okay, now we don't know what is usual speed of the aircraft, so let usual speed of the aircraft be s. So what will be the then current speed will be what? Current speed will be, it is 200 kilometer, it is reducing by 200 km per hour, isn't it? If original speed is s, then current speed will be how much? S minus 200, because from its usual speed it is reducing 200 km per hour speed, isn't it? So if s is the original speed, then current speed will be s minus 200. So now we know the formula, just now we did, distance is equal to s1 into s2 divided by s1 minus s2 into difference in time, isn't it? Difference in time. So now distance we know it is 1200, distance is 1200, which is equal to s1, speed 1 is s, and into speed 2 is s minus 200 divided by s1 minus s2. So s1 minus s2 means what? The difference in usual speed and current speed. It is 200 km per hour, isn't it? So that only is the difference in speed. So it is 200 into difference in time is how much? They are saying it is reaching 30 minutes late, isn't it? So that only is the if it has gone with usual speed, it would reach at its own time, but it is reaching 30 minutes late. So difference in time is how much? 30 minutes. So it is 30 divided by 60, because converting it into hours. So it is 30 ones are 30, 2s are, so this 200 will go this side, 2 into 200 is 400. So wait, we'll do one more step. So it is s into s minus 200, okay, divided by 400, 200 into 2. So it is 1200 into 400, which is equal to s into s minus 200. Okay, so 12 into 4 is 48 and 4 zeros, which is equal to s into s minus 200. You might be thinking why I am not solving s into s minus 200, because if we solve it will become a quadratic equation. It becomes s square minus 200s, isn't it? And then taking roots and all will be very difficult. So instead of that, we can take options method. Okay, from options we can directly take one option, put in this equation, and then we can find out. Okay, so we'll take first option 800. So if I take 800, what it will become? 48, 4 zeros, which is equal to 800 into 800 minus 200. So it is 48, 4 zeros, which is equal to 800 into 800 minus 200 is 600. So it is 48 double 0 double 0, 8 6 are 48, and these two zeros, 2 zeros. So this first option is satisfying. LHS is equal to RHS, isn't it? So that means the speed is 800 kilometer per hour. So the usual speed was how much? 800 kilometer per hour. So option A itself is the answer. Okay. So don't take it as quadratic equation and find the roots. It will take a lot of time. Directly you can take one option, put in this equation, and whichever option will satisfy this equation, that will be the answer. Now going to the next problem. An aeroplane is stopped for half an hour and now it has to cover a distance of 1500 kilometer in given time. So its speed is increased by 250 kilometer per hour. Find its initial speed. Okay. An aeroplane is stopped for half an hour, maybe because of bad condition or anything. It was stopped for half an hour, and then it had to cover a distance of 1500 kilometer in the same given time. Okay, whatever time means, if it had to reach 1500 kilometer in 5 hours, it has to reach that much only. But what has happened? Half an hour is already wasted. So in the remaining 4.5 hours, it has to reach 1500 kilometer. So in the remaining 4.5 hours, if it has to reach the same distance, then it has to increase its speed. So when it increases its speed, then only it can reach in the given time, isn't it? So its speed is increased by 250 kilometer per hour. So what is its initial speed? So if it had not wasted that half an hour, what was the initial speed with which it had to travel? Okay. So same way as we saw it earlier, let we do this. Let usual speed or initial speed, okay, let initial speed of that aeroplane be yes. Okay, then what is current speed? Current speed of that aeroplane is how much? It is increased by 250, isn't it? If it was yes initially, it is increased by 250. So it is now yes plus 250 kilometer per hour speed. So therefore we know the formula, that is distance is equal to speed into, so okay, S1 will take directly S1 divided by S2 for this, S1 minus S2 into difference in time. Okay. So speed 1 we know it is yes, and speed 2 is yes plus 250 divided by the, so difference in speed is how much? See, if it was yes earlier, now it has become 250 extra. So the difference between initial speed and current speed is 250, isn't it? So difference in time is how much? It is half an hour. It is reaching late, isn't it? So that 30 minutes itself is the difference in time. So it is 30 divided by 60. So 1s are, 2s are, and different distance we know it is 1500. So it is 1500 into 250 into 2 is 500. So that 500 will come here, which is equal to yes into yes plus 250, isn't it? So 15 into 5 is 75, and these 4 zeros, which is equal to yes into yes plus 250. Now again we'll see with the options method. We'll try with the options method. Okay, from options method. So first option was 1000 kilometer. So we'll see with 1000 kilometer. So it is 75,000. So it is 1000 into 1000 plus 250 will be 1250. Okay. So it is, now if you multiply 1250 into 1000, it is 1250 3 zeros, which is not equal to this 75 7,50,000. Okay, so this is not equal. So option 1 is not fine. So we'll try with option 2, which is 750 kilometer per hour. Okay, so it is 750 into 750 plus 250 is 1000. So it is 750 into 1000 is 75 and these 4 zeros, which is equal to this, isn't it? So therefore B, option B itself is the answer, that is 750 kilometer per hour is the answer. So the initial speed was how much? 750 kilometer per hour. Okay, so this is the answer. So we'll go to the next problem.